Hello everyone. So in this video we are going to discuss about CRT, or you can say Chinese remainder theorem. So what we are going to discuss, we will discuss the statement of Chinese remainder theorem, what Chinese remainder theorem states, and then we will solve it we will check some examples of Chinese remainder theorem. So Chinese remainder theorem says that this theorem is used to solve a set of different equations. It used to solve a set of different congruent equations, set of different congruent equations with one variable, set of different congruence equation with one variable but different moduli, which are relatively prime to each other, which are co-prime or relatively prime to each other. For example, we write x is congruent to a1 mod m1, x is congruent to a2 mod m2, x is congruent to a3 mod m3, and so on up to x is congruent to an mod mn. And these equations are given, and what we have to do, we have to find the value of x, which is, so that's why we say that equation with one variable x is 1 and modulus m1 m are different, and these all m1 m2 m3 are co-prime or relatively prime to each other. So this is the statement of Chinese remainder theorem, and this theorem is used to solve the value of x. And how we can find the value of x? Value of x can be found by a1 capital M1 m1 inverse plus a2 capital M2 m2 inverse plus a3 capital M3 m3 inverse up to an capital Mn mn inverse whole modulus capital M. So now what is the value of, now you may be thinking that what will be the value of m1, what will be the value of m2, what will be the value of m3, because we know small m1 is small m2 small m3. By this we know small m1 a1, we know small m1, we know a2, we know m2, we know, but we do not know the value of capital M1, capital M1 inverse, capital M2. So how to find these values? So we will be checking it with the help of an example. So let's say the question states, solve the following equation using CRT, or you can say find x. And what is given to x? What is given to us? X is congruent to 2 mod 3, x is congruent to 3 mod 5, and x is congruent to 2 mod 7. So it means first we will check this. These are m1 m2 m3. So are m1 m2 m3 are relatively prime or co-prime? Yes, 3 5 and 7 are co-prime to each other. So it means this system of equation can be solved with the help of Chinese remainder theorem. So now we'll see that how we can solve this system of equation. So first check what is given to us. So given is a1 which is 2, m1 small m1 which is 3. Similarly a2 which is 3 and small m2 which is 5. Similarly a3 which is 2 and small m3 which is 7. So these are given to us. Now we have to find out capital M, then capital M1, capital M2, capital M3, and then we have to find out inverse of M1, M2 and M3. So this equation which I have written it here, this can be modified according to the number of variables. So what does it mean? So for example, we have three equations. So it means we have small m1, m2, m3, or we have a1, a2 and a3. So this equation will work up to here. If we have four equations, then we can write it for a4 also. If we have two equations, then we will write it up to a2 only. So it means if we have n number of equations, then we are going to write it up to an. So because we have only three equations, so now we can write the value of x, like x is equal to a1 capital M1, M1 inverse, plus a2 capital M2, M2 inverse, plus a3 capital M3 and M3 inverse, whole mod m. So now we need to find out these capital M's, capital M, capital M1, capital M2, capital M3, and then we can calculate their inverses also. So let me tell you the value of capital M. Capital M is going to be M1 into M2 into M3. So in this case it will be 3 into 5 into 7. So it's going to be 105. So capital M is equal to 105. Now let's come to capital M1. So you can write capital M1 is equal to small m into capital M upon small m1. So what is capital M? Capital M is equal to M1 into M2 into M3. So when we write this likewise, it's going to be M2 into M3, and which is 5 into 7, 35. Similarly, we can say that capital M2 is going to be M1 into M3, and which is 3 into 7, which is 21. Similarly, we can say that capital M3 is equal to M1 into M2, and which is 3 into 5, that is 15. So by this way we are able to calculate capital M, capital M1, M2 and M3. Now let's calculate capital M1 inverse. How we can calculate capital M1 inverse? We know that capital M1 into capital M1 inverse should be congruent to 1 mod, because small m1 is for 3. So should be congruent to 1 mod 3. So if, because just a minute. Because we know that capital M1 is congruent to 1 mod 3, and if we multiply this with capital M1 inverse, this is going to be like 1, this is going to be 1 mod small m1, which is 1 mod 3. So what is the value of capital M1 inverse mod 3? So if it is a large number, we can calculate the inverse using extended Euclidean algorithm, and we all know the method. And just because it is a small number, we can give a hit and trial method also, like it is 35. So 35 into M1 inverse is congruent to 1 mod 3. So if we put M1 inverse 1, this is not 1 mod 3. If we put it 2, so it becomes 70, and when we divide 70 with 3, the remainder is equal to 1. So capital M1 inverse is equal to 2. In the same manner, we can calculate capital M2 inverse and capital M3 inverse. So M2 into M2 inverse is going to be 1 mod M2. So M2 is 21 into M2 inverse is congruent to 1 mod M2. So either you can calculate it using extended Euclidean algorithm, which you all know that how to calculate. Otherwise, what we can do, we can put hit and trial method, and this M2 is 5. This M2 is 5. So 1 mod 5. So it's going to work for M2 inverse. M2 inverse will be 1. And similarly, we can calculate M3 inverse. So M3 into M3 inverse is congruent to 1 mod 7. So M3 is 15. 15 into M3 inverse is congruent to 1 mod 7. So M3 inverse will also be 1. M3 inverse will also be 1. So this is M2 inverse is 1, M3 inverse is 1, and we have also calculated M1 inverse, which is equal to 2, and M1 is equal to 35, M2 is equal to 21, and M3 is equal to 15, and that of capital M is equal to 105. Now we can directly put it into the equation for calculating X. So the equation is this one. Here we can write our equation A1 M1 inverse X is equal to, we can write here X is equal to A1 M1 inverse plus A2 M2 inverse plus A3 M3 inverse and mod capital M. So just putting the values, because now we have calculated all the values. So A1 is equal to 2 into M1 35, M1 inverse 2, plus A2 is equal to 3, M2 is equal to 21, and M1 inverse is equal, M2 inverse is equal to 1, plus A3 is equal to 2, and M3 is equal to 15, and M3 inverse is equal to 1 mod 105. So let me just calculate it. It is 140, this is 63, and this is 30 mod 105. So it's going to be 233 mod 105, which is equal to 23. So X will be 23. Value of X for all these equations, value of X will be 23. So this is how we can solve multiple congruence equations with the help of Chinese remainder theorem. Let's take another example. So we can have this type of examples also. Let's say 4x is congruent to 5 mod 9. Similarly, 2x is congruent to 6 mod 20. So earlier we checked Chinese remainder theorem states only when there is only x, no other constant. But here we have some constant also, and then we have to find the value of x. So are these 9 and 20 co-prime? Yes. So it means there is a chance that we can apply CRT, Chinese remainder theorem, on these equations. So the only thing is we have to rewrite these equations. So let's say we have two equations. First one is 4x is congruent to 5 mod 9. So if we multiply both these sides, like for example, if I multiply 4 with 4 inverse, it's going to be 1 and x will be x. But we have to multiply it on both sides. So 4 into 4 inverse mod 9. So here we will be getting x, and here we have to get x, we need to find 4 inverse. So 4 inverse mod 9 is going to be 7. So it will be 35 mod 9. So either you can write it as it is 35 mod 9, or you can make it short by dividing 9 and taking up the remainder. So it's always a good practice to make a small equation. So we can write it 8 mod 9. So now our first equation has been converted into x is congruent to 8 mod 9. Now the second one is 2x is congruent to 6 mod 20. So we can simply solve it 3 into 2 mod 20, and we can cancel out 2 from both sides. So x is congruent to 3 mod 20. So this is another way of just making the equation making the equation in the same format as we use in Chinese remainder theorem. Now we know that this is A1, this is M1, this is A2, this is M2, and the capital M is going to be M1 into M2, which is 180. Small m is going to be, capital M1 is going to be like M2, which is 20, and capital M2 is going to be M1, which is 9, and then we have to find out M1 inverse. So M1 into M1 inverse, M1 into M1 inverse should be congruent to 1 mod 9. So m1 is 20. So m1 inverse is going to be 5 is congruent to 1 mod 20. So this is m1 inverse. Similarly, we can find m2 inverse. So either you can put, if there is the numbers are small, you can put hit and trial method, or you can use extended Euclidean algorithm. So in this case, the m2 inverse is going to be 1. In this case, m2 inverse is going to be 9. So m2 inverse is 9, m1 inverse is 1, and now by putting the values of all these variables, we can find the value of x. So we can write x is equal to a1, and the a1 is now 8, m1 capital M1 which is 20, capital M1 inverse which is 5, plus a2 which is 3, capital M2 which is 9, capital M2 inverse which is also 9, mod m, and m is 180. So this is 800 plus 343 mod 120. So now you can easily solve 180. Now you can easily solve that what will be the value of x. So these are just two examples of Chinese remainder theorem. We can solve it for many other example, like for example, this is another question. You can take it as a homework also. So let's say x is congruent to 5 mod 3. Another x is congruent to 2 mod 5. And another one is x is congruent to 1 mod 11. So this is another question. Try to solve it yourself. Then another one is like x is congruent to 2 mod 5, x is congruent to 5 mod 8, and then x is congruent to 4 mod 37. So these are just simple questions. You need to find out the value of capital M, M1, M2, M3, their inverses, and then you can find out the value of x. Here is another example, good one. So these are the system of equations. 2x is congruent to 1 mod 3. 3x is congruent to 2 mod 5. 4x is congruent to 3 mod 7, and 5x is congruent to 4 mod 11. And then we need to find out the value of x. So first we will check that can we apply Chinese remainder theorem. So to apply Chinese remainder theorem, this 3, 5, 7 and x, all these variables 3, 5, 7 and x, this should be co-prime. So are these co-prime? Yes, they are relatively prime to each other. Now we can change the equations. Now we can rewrite the equation for x. So the first one is we can simply 2x is congruent to 1 mod 3. So in place of this we can like multiply 2 inverse both side. So 1 into 2 inverse mod 3, and it is going to be x, and 2 inverse is going to be 2. 2 inverse mod 3 is going to be 2. So it's going to be like 4 mod 3 to 2 mod 3, 2 into 1, 2 mod 3. So this is first equation. Now if we talk about the second equation, it is 3x is congruent to 2 mod 5. So if we multiply 3 inverse both sides, 3 into 3 inverse x is congruent to 2 into 3 inverse mod 5. So 3 into 3 inverse is 1, x is congruent to, we need to find out 3 inverse mod 5, which comes out to be 2. So it is 4 mod 5. Now if we talk about, if we check for the third one, so third equation says 4x is congruent to 3 mod 7. And if 4x is congruent to 3 mod 7, we are going to multiply with both sides with 4 inverse is congruent to 3 into 4 inverse mod 7. So here it comes x is congruent to, what is 4 inverse? 4 inverse mod 7 comes out to be 9. 4 inverse mod 7 comes out to be 9. So, it will be 3 into 9 mod 7. So, we can write it 27 mod 7, or if you want to simplify it, it becomes 6 mod 7. Now, the last one, fourth equation is 5x is congruent to 4 mod 11, and we are going to multiply with 5 inverse both sides. 5 into 5 inverse x, which is congruent to 4 into 5 inverse mod 11, and here we can write it 1. So, x is congruent to 4 into 5 inverse mod 11, and 5 inverse mod 11 comes out to be 9. So, 4 into 9 mod 11. So, either we can write it 36 mod 11, or if we want to simplify it, we can write 3 mod 11. So, now we have rewritten the equations. So, we have all the all the variables. This is a1, this is small m1, this is a2, this is small m2, this is a3, this is small m3, and this is a4, this is m4. So, we can calculate capital M. Capital M comes out to be m1, m2, m3, m4, m1, m2, m3 and m4, and which is equal to 3 into 5 into 7 into 11, and which comes out to be 1155. And similarly, we can calculate capital M1, which will be m2, m3 and m4, and it comes out to be 385. Similarly, we can calculate capital M2, which is m1, m3 and m4. It comes out to be 241. Similarly, we can calculate m3, which comes out to be 165, and we calculate m4, which comes out to be 105. So, now we have capital M, capital M1, M2, M3 and M4. Now, you can calculate inverses of M1, M2, M3 and M4 either using it in trial, or the best thing is you should use, for large number you should use extended Euclidean algorithm. So, once you calculate all inverses like M1 inverse, M2 inverse, M3 inverse and M4 inverse, just put the value in the equation. X is equal to A1 M1 M1 inverse plus A2 M2 M2 inverse plus A3 M3 M3 inverse plus A4 M4 M4 inverse whole mod capital M. So, you can solve the value of x by using this method. So, this is all about Chinese remainder theorem, how we can solve the systemic equations using Chinese remainder theorem. So, thank you. In the